Imagine waking up to a headline that shakes the very foundation of what we know about the universe. Scientists just detected something impossible in space. It's the kind of news that makes you stop in your tracks, that sends a chill down your spine, that makes you question everything you thought you understood about reality. This isn't just another story about a distant star or a new exoplanet. This is about a discovery so strange, so unexpected, that it threatens to rewrite the laws of physics themselves. And it all started with a signal, one that no one could explain. Let's set the scene. In the early hours of a quiet morning, deep within a remote observatory, a team of astronomers is monitoring a bank of screens. They're used to seeing the usual cosmic noise, the steady hum of background radiation, the occasional blip from a passing asteroid, the rhythmic pulses of distant pulsars. But then, something different appears. A signal, sharp and clear, cuts through the static. It doesn't match any known pattern. It's not a radio burst, not a gamma ray flash, not the signature of a black hole or a supernova. It's something else, something that, according to our best theories, simply shouldn't exist. The team springs into action. They check their instruments, rule out interference, and cross-reference data from other observatories around the world. The signal is real. It's coming from a region of space that, until now, was thought to be empty. No stars, no galaxies, no known sources of energy, just the cold, dark void. And yet, here it is, a pulse of energy, repeating at regular intervals with a structure that defies explanation. Word spreads quickly through the scientific community. Astrophysicists, cosmologists, and particle physicists all weigh in, offering theories and counter-theories. Some suggest it could be a new kind of neutron star, spinning faster than anything we've ever seen. Others propose it might be the signature of dark matter, finally revealing itself after decades of searching. A few even whisper about the possibility of alien technology, a message from an advanced civilization reaching out across the cosmos. But as the data pours in, one thing becomes clear. Whatever this is, it doesn't fit into any known category. The implications are staggering. For decades, the laws of physics have been our guide to the universe. They've explained everything from the motion of planets to the behavior of subatomic particles. But this signal doesn't play by those rules. It's as if the universe is sending us a message. You don't know everything. There are still mysteries out here waiting to be discovered. The search for answers begins in earnest. Teams around the world point their telescopes at the source, gathering data across the electromagnetic spectrum. They look for patterns, for clues, for anything that might explain what they're seeing. But the more they learn, the stranger the signal becomes. It shifts in frequency, changes in intensity, and sometimes disappears altogether, only to reappear days or weeks later. It's as if the universe itself is playing a game of hide and seek. As the weeks turn into months, the mystery deepens. The signal is unlike anything in the astronomical record. It's not a fast radio burst, not a pulsar, not a quasar. It doesn't match the signature of any known cosmic event. And yet, it's undeniably real. The data is clear, the instruments are working, and the signal persists. This is where the story takes a turn. In science, the most exciting discoveries often come when something doesn't fit, when the data refuses to conform to our expectations. It's in these moments that the boundaries of knowledge are pushed, that new theories are born, that the universe reveals its secrets. And this signal, impossible as it seems, is one of those moments. The scientific community is abuzz with speculation. Some propose that the signal is evidence of a new kind of particle, one that interacts with matter in ways we've never seen before. Others suggest it could be a ripple in space-time itself, a gravitational wave from an unknown source, bending the fabric of the cosmos in ways that defy Einstein's equations. A few even argue that it might be a glitch in the simulation, a sign that our reality is not what it seems. But amid the excitement, there is also caution. Extraordinary claims require extraordinary evidence. The team behind the discovery knows that they must rule out every possible explanation before they can claim to have found something truly impossible. They invite independent researchers to review their data, to replicate their findings, to challenge their conclusions. The process is rigorous, methodical, and transparent, the very essence of the scientific method. As the investigation continues, the world watches with bated breath. News outlets pick up the story, social media buzzes with speculation, and the public is captivated by the idea that we might be on the verge of a new era in science. The signal becomes a symbol of the unknown, a reminder that the universe is still full of surprises. But what exactly have scientists detected? What makes this signal so impossible? And what could it mean for our understanding of the cosmos? To answer these questions, we need to dive deeper into the data, into the theories, and into the minds of the scientists who are racing to solve the greatest mystery of our time. To truly grasp the magnitude of this discovery, we need to step into the shoes of the scientists at the heart of the investigation. Imagine the pressure, the excitement, and the weight of responsibility. Every new observation, every data point could be the key to unlocking a new chapter in our understanding of the universe. Or it could be a mirage, a trick of the instruments, a fleeting anomaly that vanishes under closer scrutiny. The stakes are enormous and the world is watching. The first step is to rule out the mundane. Could the signal be a product of human technology, an echo from a distant satellite, a stray transmission from a passing aircraft, or interference from Earth-based electronics? The team meticulously cross-checks their data, comparing observations from multiple observatories on different continents. The signal is consistent, appearing at the same coordinates in the sky with the same peculiar characteristics. It's not a local phenomenon. It's coming from deep space. Next, they consider known cosmic sources. Pulsars, for example, are rapidly spinning neutron stars that emit beams of radiation, sweeping across the cosmos like cosmic lighthouses. But pulsars have a distinctive signature, a regular clockwork-like pulse that can be predicted with astonishing accuracy. This new signal is different. Its intervals are irregular, its frequency shifts unpredictably, and its energy output fluctuates in ways that defy explanation. It's as if the source is alive, responding to some hidden rhythm that we can't yet decipher. Quasars, too, are ruled out. These are the blazing hearts of distant galaxies, powered by supermassive black holes devouring matter at a furious rate. Quasars are among the brightest objects in the universe, but their emissions are chaotic, not patterned. The signal in question is both structured and mysterious, a paradox that deepens with every new observation. As the investigation continues, the team turns to the most exotic possibilities. Could this be evidence of dark matter, the elusive substance that makes up most of the mass in the universe but has never been directly detected? Dark matter is thought to interact with ordinary matter only through gravity, making it invisible to telescopes. But some theories suggest that under the right conditions, dark matter could annihilate or decay, releasing bursts of energy detectable by our instruments. Could this signal be the first direct evidence of dark matter in action? The idea is tantalizing, but the data doesn't quite fit. The energy levels are off, the timing is wrong, and the location doesn't match the regions where dark matter is thought to be most concentrated. The team is forced to look elsewhere, to consider even stranger possibilities. One theory begins to gain traction. The signal could be a new kind of astrophysical object, something never before seen. Perhaps it's a blitzer, a theoretical object formed when a massive neutron star collapses into a black hole, releasing a final catastrophic burst of energy. Or maybe it's a cosmic string, a relic from the earliest moments of the universe, vibrating across the cosmos and sending out pulses of energy as it snaps and reconnects. These ideas are on the cutting edge of theoretical physics, and they push the boundaries of what we consider possible. But as the theories multiply, so do the questions. If this is a new kind of object, why haven't we seen it before? Why is the signal so regular yet so unpredictable? And what could be powerful enough to send a signal across billions of light years through the vast emptiness of space and still be detectable here on Earth? The team decides to dig deeper, analyzing the signal in unprecedented detail. They break it down into its component frequencies, searching for hidden patterns. They compare it to every known cosmic event, from supernova to gamma-ray bursts to the mysterious fast radio bursts that have puzzled astronomers for years. Nothing matches. The signal stands alone, a singular anomaly in the vast tapestry of the cosmos. At this point, the story takes on a life of its own. The scientific community is divided. Some argue that the signal is a fluke, a statistical outlier that will disappear with more data. Others are convinced that it's the first glimpse of a new frontier, a sign that the universe is more complex and more wondrous than we ever imagined. Debates rage in academic journals, at conferences, and in late-night emails between collaborators scattered across the globe. Meanwhile, the public's imagination is captured by the mystery. News outlets run headlines about impossible signals and messages from the stars. Social media buzzes with speculation, from the plausible to the fantastical. Is this proof of alien life? A glitch in the matrix? A sign that the laws of physics are about to change? The scientists, for their part, remain cautious. They know that extraordinary claims require extraordinary evidence. They continue to test, to question, to challenge their own assumptions. They invite independent teams to replicate their findings, to scrutinize the data, to look for flaws in the analysis. The process is slow, painstaking, and sometimes frustrating, but it's the only way to be sure. As the months pass, the signal persists. It appears and disappears, shifts and changes, always staying just out of reach. It's as if the universe is teasing us, offering a tantalizing glimpse of something beyond our understanding, then pulling back the curtain before we can see the whole picture. But even as the mystery deepens, one thing becomes clear. We are on the brink of a new era in astronomy. The tools at our disposal, powerful telescopes, sensitive detectors, sophisticated algorithms, are more advanced than ever before. We are able to peer deeper into the cosmos, to detect fainter signals, to ask bigger questions. And with each new discovery, we are